I'm very happy today to speak with Christophe Fouquet, CEO of ASML. ASML is a Dutch multinational corporation specialized in the development and manufacturing of photolithography machines used to produce integrated circuits, also known as chips. We'll explain all of this in a minute. ASML is the largest supplier of such equipment in the world and the only one capable of offering the kind of technology required to manufacture the most advanced chips. This technology is called extreme ultraviolet EUV lithography. ASML employs more than 44,000 people and generated 28 billion euros of revenues in 2024. With margins around 50%, this translates into a market capitalization of about 250 billion euros, making it not only the second most valuable tech company in Europe, right on the heels of #1 SAP, but these days, SAP and ASML are actually the most valuable European companies, period, across all sectors. Christophe joined ASML in 2008 and rose through the ranks to join the management board in 2018 and become president and CEO in April 2024. Prior to ASML, he studied physics in Grenoble, in France, and he worked for about 10 years at Applied Materials and KLA-Tencor, two companies also supplying the semiconductor industry. Christophe, thank you for welcoming me onto ASML's magnificent Veldhoven campus, and thank you for making the time to be with me.
Oh, you're very welcome. Very, very happy to have you here. I'm very happy also to share with you some great things about this industry and about ASML.
So speaking of industry, when we think of chips these days, the names that come to mind, of course, are Nvidia, TSMC, and ASML. Let's clarify who does what and why they're all successful. Now, Nvidia has recently reached, I think, $4 trillion market capitalization, designing and selling chips that were initially designed for gaming and, of course, have been powering the extraordinary AI ramp-up. But they don't manufacture these chips, do they?
No, they don't. I think this is done by another company, mostly today, TSMC, which I think is one of the three companies you mentioned. So the manufacturing of the chips is indeed today done in Taiwan, which also creates a lot of geopolitical discussion.
Right. But so it means that they design chips. Are there other organizations that only design? Are there some that design and manufacture?
Well, I think TSMC a few years ago had this great invention called foundries. And what the foundry does is basically offer the ability to anyone that designs chips to manufacture those chips. So by offering this service a few years ago, TSMC really broadened, I would say, the range of this industry. So today you have a lot of companies who are designing chips and use foundry service to manufacture them. So Nvidia is by far the most known of them today because of its importance in AI in the last few years. But you're looking basically at dozens, if not hundreds of companies.
Including Apple, for example.
Including Apple, including Qualcomm, Broadcom, AMD, and many, many others. So this is a very, very large set of people doing chip design.
So these folks design, then TSMC and a few others manufacture. I think TSMC has about a 60% market share. And then you design and assemble extraordinary complex machines that supply people like TSMC who make those chips. So tell us how your products fit in the production of a chip and what role they play.
Well, so to create a chips, you have many, many different process steps. It takes months, basically, to create a chip at TSMC or at Intel or at Samsung. And in order to do that, you have several critical steps. One of them is called lithography, and this is the step that basically allow our customer, like TSMC, to print the structure, if you want, of the electronic circuit on the wafer. And it's a very important step because it defines also how much density of transistor you will get on the wafer. And the smaller you can print the transistor, the higher the density you will get on the wafer, and the more powerful the more energy efficient your chip is going to be.
And very briefly, for those of us who are not experts, after the photolithography, what happens?
So after that, there is a development process. It's a bit like photography. So the lithography will expose part of a material called the resist to define the pattern. Some of it has to be removed. Then the material has to be etched to create the structure. Then it has to be filled by other elements to isolate. And then we need to go to the next level. So we're going to deposit some new material. So that's a deposition step. Do photolithography again, etch again, etc., etc. And you do that sometime several hundred times to create the chips, basically.
Okay. Now, just to be clear, this is incredibly complex. Your machines, I think, have over 100,000 parts, kilometers of wire, and they need to be assembled here once, but then you need to disassemble them and reassemble them at your client's premises.
Right. So I think one of the reasons why it's very complex is everything we describe, this chips fabrication, it's high volume manufacturing. So we need to create machines that not only can print those chips, but they have to do that at very, very high speed, at very, very high reliability, because these are the tools that are being used to run factories. Our system can expose 3,000 wafers per hour. Every wafer will have about 1,000 chips. You're looking at chips now with 150 billion transistors. So the number of transistors our machine can print per hour is enormous. And it has to be like this so that you can build the entire economy on it. So we need to be fast, we need to be reliable.
And I think it's important for, again, people watching to understand the accuracy levels. So you have mirrors supplied by Zeiss. We'll come back on this. I read that if the size of the mirror was extended to the size of Germany as a country, the highest that the mirror would go is 0.1 millimeter, meaning this is like incredibly flat. And a human hair is like 1/10 of a millimeter, and you guys are operating at 1/10,000th of that.
Yeah, so we talk about picometer. Picometer is 10 to the minus 12 meters, so extremely small. And the reason for that, it starts with the resolution of our machines. The INA EUV machine, which is the latest from ASML, has a resolution of 8 nanometer. Right, took the example of the human hair. A human hair is 80,000 nanometer. It means that we are 80,000 times more precise than the size of human hair. So this is what we print basically on the wafer. Now, to be able to print that on the wafer, the image you're going to bring to the wafer has to be also perfect. And that's realized by the mirror. And the mirror have to be absolutely perfect. And Zeiss, together with ASML, have spent also many years to develop technology to be able to do that. And the mirror we use today on INA are by far the most advanced optic you can find. You know, we used to be very impressed about things like the Hubble telescope, right, in space. If we look at the quality of our mirror today, this beats that by a very large factor.
And this light is produced by essentially zapping 50,000 thin lead drops per second.
Right. So we are at 60,000 today, so we went even faster. And that's another thing that is quite extraordinary. So EUV light doesn't exist around us. Right. The one place where you can find EUV light is the sun. And EUV light is on the sun because there is a very high density, high temperature, high pressure plasma that create that light. So of course we don't have that on Earth, but we had to recreate those conditions in our machine. And the way we do that, we indeed hit a thin droplet with a very powerful CO2 laser, which is more than 30 kilowatt. And when we hit that droplet, we create some EUV light. We do that 60,000 times per second. And in fact, we don't hit the droplet once, we hit it 3 times. So 2 times to make it bigger, so that when we hit it basically with the CO2 laser, we get as much light as possible. So that little story in ASML took almost 20, 25 years to come to reality. just to give you an idea of the complexity of the physics behind that.
So hopefully by now, everybody watching us is understanding the complexity of the machine and the extraordinary sophistication. Now, one of the things that most of us have heard of course, is Moore's law, where the idea is that the density of transistors will double every 2 years. And so far, so good. This has held for about 50 years. And is it fair to say that over the last few years, certainly, it's in large part because of ASML? Because if you guys don't set the initial density, it doesn't come later. Is that fair?
Do we play an important role in Moore's law? Yes, because lithography enables shrink, and that supports more density. So litho is very important. We play a big role, but are we the only one driving Moore's law? Absolutely not. I think there's many other companies. If you take them out of the ecosystem, then Moore's law stop. And I think this has been something this industry is very, very proud. It's an history of collaboration where many companies have to play a unique role. We do things no one else knows how to do, but a lot of people do things that we have no idea ourselves how to do. So we have to do that together. So we play a very important role, but not by ourselves. If you allow me also on Moore's law, the industry has done pretty well keeping Moore's law going, doubling density every 2 years. AI has in fact accelerated that.
Right.
So now when you look at AI needs for transistor density for...
more than twice.
It's more than twice. It's 16 times every 2 years. So there's been an explosion of demand for transistor density and energy efficiency. The two goes always together. And this has, I will say, put the whole industry on steroids, because we have to do even more now, right? Our customer, TSMC, Intel, Samsung, have to move on their roadmap even faster because their customer, like Nvidia, wants even more performance on their chips. So AI, if anything, have created a demand for acceleration of Moore's law, which is a bit what we deal with today.
And so far, we've been able to do twice every 2 years. Is it feasible, 16 times every 2 years?
So you have to do other things. So you cannot do it only with lithography. So what is happening in the industry is a lot of redesign of the chip architecture. Something that became very important is advanced packaging, where our customers are starting to assemble basically different chips together, because that's another way to get basically the density. So this is really creating or requiring a lot more innovation for this industry moving forward.
So you guys have been coming up at the right time, of course, with more sophisticated machine. We had DUV, and then we went to extreme ultraviolet, EUV, and then high numerical aperture ultraviolet. So if possible, briefly, what's the difference between DUV and EUV and between EUV and high NA?
So it starts again with the resolution we try to achieve. I talked about critical dimension before. Critical dimension is the size, the smallest size of a line we can print on the wafer. And like I said, the smaller, the better for transistor density. That critical dimension is proportional to the wavelength of our system and is inversely proportional to the numerical aperture of our system.
Okay.
When we talk deep UV, when we talk EUV, we talk about the wavelength. So the main difference between deep UV and EUV is the wavelength. The last wavelength for deep UV is 193 nanometer. The wavelength of EUV is 13.5 nanometer. So you see a major improvement as a result in the resolution. So this is the top, if you want, of the equation. And then when you talk about INA, it's in the name, you talk about the numerical aperture. The INA tool has a 0.55 numerical aperture versus a 0.33 for what we call EUV today. Now that's the bottom of the equation, and by increasing the INA, we again improve the resolution. So resolution of EUV today, low NA, has 13 nanometer. Resolution of INA is 8 nanometer. So that's what it is. And our whole lithography world is about driving the wavelengths down and trying to drive basically the numerical aperture up. This is what we've been playing with for the last 40 years.
Increasing the numerical aperture means bigger mirrors. And of course, all of this means from DUV to EUV to high-NA, more costly machines. You've said we increase the density of the transistors. The value proposition for the customer is you're going to pay more upfront, but then?
Yeah, so the value proposition is that the cost of the printed transistor always goes down.
Okay.
Right, so there's no machine we make in ASML that does not reduce the cost of making a chip. Any machine that will make a chip more expensive, a customer will never buy.
Okay.
Because that has to scale down basically while the density scale up.
So higher density, I think better yield also, and better throughput because less movements. And also as you do this, I guess it also lowers the environmental impact because you're using less electricity in the process.
Correct. You use less electricity and you remove the need for some of the other processes like etch, like deposition, that are also using a lot of electricity, but also a lot of chemicals that are not great for the environment. So if you look at lithography, the only thing we really use is electricity and water to cool down the system, no chemical, and of course chemical also have quite a negative impact on the environment.
And you mentioned earlier the ASML cost per chip, so that's something that you guys monitor and track.
Yes, something we monitor, we track, something we discuss with our customer all the time, something we're very, very proud of. That's a bit our own Moore's law, if you want. If you look at the history of ASML, we have been driving down that cost systematically year after year with our machines.
Of course, the big question is, will China be able to make these kinds of very high performance chips by themselves? And what I've read is that China is indeed making lots of progress in chip design and manufacturing, but most of the things I read said, but in lithography, now that's an entirely different ballgame because of the excellence required in multiple fields, including optics, mechanics, chemistry, mathematics, and so on. So what makes ASML so unique?
Well, I think the technology first. I think lithography is a complex technology. Every step you make in lithography require a change in the wavelengths, which require a change in the optic, require more accuracy over time. So it's a lot of innovation together. The second thing, Europe is always a bit looking at itself with some poor eyes compared to the US.
In a self-deprecating way.
Yes, but the entire supply chain of lithography is here in Europe, very concentrated. 80% of our suppliers are in Europe. When it comes to the most critical part, 100% are here. I could mention Zeiss, I could mention TRUMPF, I could mention VDL. They have all been working with us to not only supply parts, but to design every time the next generation of parts. So they are investing also very heavily, basically, to make things better. And this is concentrated around us. And I think the other element, if you look at California, which is the place where most of the other equipment suppliers are, California was built basically with engineers coming from all over the world. And those engineers sometimes goes back, right? A lot of them went back to China, for example. And when they go back, of course, the knowledge also goes with them. And that's also something that, for historical reason, we have not done here in Europe. I think if we look at our workforce, it's still very, very localized. So there are a few key factors that makes lithography a far more difficult technology to reproduce. Right? And today, only Japan and Europe have been able to do that.
Right. Now, you mentioned Zeiss. Of course, one of your suppliers is Cymer, but this one you own. Zeiss, you bought 25% of, and I was just curious, do you have an exclusive agreement with them, or could they sell to somebody else?
No, we have an exclusive agreement for many, many years. So we have a very nice marriage of interest and marriage of innovation, and this has been working extremely well for many, many years. And the reason we did that was to make sure that the interdependency we were creating between each other was positive.
Okay.
And we cannot do our scanner without Zeiss,
Right.
and Zeiss cannot sell their optic without our scanner. So there's a very, very strong common interest, and exclusivity has allowed us basically to drive without second thought the technology roadmap together very, very aggressively, which was absolutely critical for EUV. And I would say our participation in Zeiss was another sign of that. And it came at a time we were developing INA. Those things are very costly. And this was also our way to put even more skin in the game, invest even more so that we could also enable basically the INA technology.
So you've mentioned the importance of the dense network of outstanding suppliers. One thing I was curious about is, what's the importance of accumulated expertise? So obviously there's extraordinary R&D and design. Is there also like know-how that's required?
The know-how is absolutely essential. First for R&D, so there's no way you can make the existing machine without having done the previous one.
Okay.
And the previous one, and the previous one. So the learning is constant, and you have to keep the knowledge, right? And this is very, very essential. It's been one of our challenges when we grew so fast. We were hiring a lot of engineers.
Yes, I'll come back on this.
We had to make sure that they had to learn what's happening here, because that's not something you learn at school. So the know-how is critical. Here, but also later on at our customer, the understanding of how the machine works. So this is absolutely essential to make lithography.
One of the things that's regrettable about machines is that they're one-off revenues. But of course, when you start having as large an installed base as you guys have, you can also create recurrent revenues with services. I think right now services are a little bit over 20% of your revenues, but those are different activities. How challenging is it to have these two different sets of activities?
Well, I think you're right. They're completely different competencies. Both generate huge value for our customers. So the machine itself, I think we understand by now that this enables their technology. The service enables two things. The first one is the tool being able to run all the time, because if a customer buys a tool, 50% of the time it doesn't work, then the cost is twice as expensive than if it runs all the time. So the service is there to keep our machine up and running all the time. And the other thing is to extend the lifetime of the machine. And our machine today, some of them we have shipped 30 years ago, they're still running, right? So machines go, I think that's also pretty good when it comes to environment. The machines are there for many, many years. And that's going to be true also for EUV, all right? We are preparing ourselves to maintain, to service those tools for the next 20, 30 years. And these are very, very important discussion and value for our customer.
Demand for these more sophisticated machines, of course, is largely driven by the development of AI and the humongous amount of computing power that this will require. Do you see the development of AI as an unstoppable phenomenon, or might we have some crisis along the way if nobody can monetize these investments?
Well, so I think that the need to monetize is, of course, critical, because you cannot invest forever billions of dollars without having any return on that. Do we have any concern on that? I think not, because we, even at ASML, see the value of AI. So we're bringing this technology in the company. We see how it could improve the performance of our product. We see how it can shorten the cycle time in R&D, in operation. So we ourselves, I would say, are becoming a very eager customer. And I would say the faster AI reach great performance, the more we will use it. And I think it's going to be true over time for many applications. Healthcare for sure, energy, I'm sure you'll come back to energy at some point. I think AI can help a lot to optimize energy consumption. Anything pretty much we see around us, I'm convinced will have some of those applications. And it's a matter of time, maybe 2-3 years, until you have on your phone, on your PC, on your car, some really useful, it has to be useful, right? It should not only be cool, but useful application that basically allow some company to really monetize AI. So I think this will come. There's a big debate if it comes in 2 years, in 3 years, in 4 years, you know.
But it's unstoppable.
It's unstoppable.
And you've already mentioned the environmental demands, right, or the impact on the environment that this increasing power comes. Now, you guys, of course, have strong commitments to be greenhouse gas neutral by 2025 on scope 1 and 2, and then 25, 30, and 2040 on some aspects of scope 3. But overall, you know, we see data centers are going to require so many percentage of this. From a non-expert observer position, it doesn't look super sustainable. You're confident that society will be able to make this work?
Well, I think, you know, energy efficiency has always been a very important driver also of this industry. So we talked about the transistor density. This is the very well-known Moore's law. If you talk to our customer, if you talk to a company like TSMC, they will tell you that driving down energy consumption in the last few years was more important than driving density up. Because even for mobile application, battery lifetime has been an issue. So power consumption is the other element of Moore's law. This has been going down per, you know, for the same chip over time. Now AI, with this 16-time density per 2 years, is going a bit off the chart. And if nothing is done, we've done some calculation, it shows that by 2035, you need to allocate the entire world energy to AI.
Right.
Won't happen, of course. It won't happen, and what have to be done is work extremely hard on making AI more energy efficient. How do you do that? First, you work on models. You know, when the DeepSeek guy came around with their new model, people thought it was a terrible news. I think I was one of the first ones to say, well, that's a very good news, because this is the sign that models can lower the need for chips. And this is important for AI to continue. So model has to improve dramatically, and the chips themselves have to improve.
Right.
That's where we come back together with our customer in play to continue to design architecture, processes that will result into less energy consumption. So it's a tough battle, but everyone should be very motivated, because like I say, you're not going to allocate the entire world energy to AI. So we have to address that. We have done it before with Moore's law. If you look at the energy that the first computer was using, and if the current computer were using the same amount of energy per transistor, you already allocated the whole world energy to PC. So I think we have seen some of that also in the past.
So you're confident?
I'm confident because, you know, the AI opportunity is enormous. This industry has been very strong at, I would say, realizing this kind of work in the past. And I think that people who are working on the models are also extremely aware that they have to have more efficient model.
Now, let me shift my questions to a more organizational angle. Over the last 10 years, ASML has grown remarkably fast, essentially doubling revenues and number of employees kind of every 5 years. As a result, about half of your employees have been hired over the last 5 years, which means considerable challenges in terms of A, recruitment, and B, induction. Let me start with the recruitment. How do you recruit 4,000, 5,000, 6,000 people per year, especially given that, as you said, it's not like there are many competitors that you can go and hire from?
Yeah, so to be honest, I think maybe 7, 8 years ago, this was a very scary question for us, because I think we didn't know how to do that. And we had a bit of a deficit of fame. People didn't know us. So it was even difficult to get people studying in the north of the Netherlands to come live here in the south.
Interesting.
Because they didn't really know ASML. So what has helped us is the recognition of ASML as an important company, and that came with EUV. EUV has changed a lot of things for ASML. And then the next challenge came, which I think is a much bigger one, which is how do you make sure that, you know, you train those people so that they are not disappointed.
I know that you're also quite focused on making sure that we don't lose the cultural aspects that have made ASML a great company.
Yeah. Yeah, so there also the challenge, of course, the volume. One thing that plays for us is people come to us because of the culture, right? They come to ASML because they see ASML as an innovation powerhouse. They see ASML as a company that is very close to customers, so that's what they look for when they come to us. And those principles, innovation, customer first, working as a team, collaboration, making sure we care about each other, these are things that we repeat, all the time from day one. And that's true at the leadership level, but it's also true, I would say, at the management level. We are all extremely attached to this. You could say maybe because this is what made our success. But I think more importantly, it's because what makes ASML such a great company to work for. I think if you look at ASML, when the CEO comes to the office, he smiles. But the same with engineers. So we have a bit this idea that we are in a place that is unique and really extraordinary. And we like it. And we want to keep it this way. So this is, I think, also playing positively in our ability to keep the culture. But that's also, you need to be a bit aware of it. Right. So there's also work to be done to keep that.
That's what I was about to say. So it's one thing to be aware that we're jointly responsible, but it's another thing to say, and so let's act jointly responsible. So you're saying your top team and the leadership, I guess, hierarchy is conscious of the role that they play in nurturing the values of the company.
They're conscious, they interact also. So, still a company where, I can have technical review with a team. So that's part of the culture where the CEO can still sit with the team and have, 2 hours discussion on a new source or a new piece of optic. We still do that. We can all together gather if we have big problem with customer. So we stay very close to the content, meaning we still understand what we do, right? There's no one that has a senior position without really understanding what ASML is about, without understanding what the customer are about. And then we have this interaction, right? I think the management team, the leadership team is extremely accessible. There's no hierarchy, mental hierarchy. People can come and talk to anyone. And this also contributes to that culture. So ASML is a big company today, 44,000 people.
44,000, they told me, yeah.
It still feels like a family, right? We know each other well, and there's no barrier to talk or to...
Low power distance.
Exactly. Sometimes people say, it's one of the company with people who join us, they say, well, we don't see politics in ASML. Of course, there's politics, right? It's a big organization, but what they mean is that this is not what people drive. They drive the company, they drive the value for our customer, and that's more important than a lot of things that sometimes companies focus on. So that's also part of the culture.
I want to build on this and ask immediately, the stock price of ASML has been shifting dramatically, right? Doubling, having. And the sense I have is, of course, you guys care about this, right? But the sense I have listening to you today and also watching you in other interviews is, it seems that you guys seem to feel a sense of responsibility to the industry and to society in general, more than other companies I've seen. Is that fair?
Yeah, I think it's extremely fair. I think our sense of responsibility toward the industry is enormous. So, this was one of your first questions. We understand the critical place we have. And if you are in a critical place, you need to be responsible for it. Some people could say, oh, yeah, we are in this critical place, so let's abuse everyone, increase our price, and make more profit. This works if things don't move. But this industry is always about going to the next step. And we're a critical, element of going to the next step.
Right.
And that responsibility is huge. And that's also true for our customer. And that's why we have this very, very strong relationship with our customer. We discuss what will happen in 10 years. And then we work on what will happen in the next 10 years. And that responsibility, that belief that I would say the best is to come, give ASML a very long-term view. So some company likes to focus on the short term. We are a company that focuses on the long term. Everything we do has to do with, the next 5, 10 years. We are spending a lot of time on that. And to go back now to, the question on the stock market, of course we care about this because we also care about our shareholder. But the message to our shareholder is the long term is what ASML can work on. Having the right product, having the right relationship with our customer, entering market that will be critical moving forward. If we do all those things, our position will be very good. And then you have the rest. You have the macroeconomy, you have the geopolitics, and that part creates a lot of the uncertainty, a lot of the swing. So, if you look at the history of course. Every time there was an article about China, our stock went down 10%, right? Wow, that's a bit high price, but that's what's happened. Can we control that? No. What we can control is the value we generate as a company, our long-term view of the industry, the market. And if we do that, well, there may be a few storms, but the sun will always come back. And when you have a storm, the stock will do like this, and when the sun comes back, it will go back to, the place where the value we generate should put it. That's a bit the way we look at it. There's things you cannot control. Even as a CEO, you realize that you have things you cannot control.
Now, one of the things that is important within the ASML is neurodiversity. The idea that all of us are different in terms of the way we perceive reality, approach work. And I think ASML has been more active than a number of companies I've seen in trying to support individuals that are considered neurodiverse. How did this come about?
Well, I think because that goes back to the culture and our history. I think we are convinced, deeply convinced, that diversity is a key component of our success. If you want to innovate fast, smart, you need to have this ability to bring many, many different people together, to give them a space where it's safe to debate and where people can have completely different idea, out-of-the-box idea. And we have seen that diversity helps in that. And that's also true for neurodiversity. And, this is not new for ASML. I think, a lot of people who are extremely good in science, who are extremely good in innovation, have a bit of that.
So maybe you have a few more neurodiverse individuals in your R&D population.
I think so, but I think that, we didn't use this term maybe 5, 10 years ago, but I would say, everyone already had its space. I think we enjoy that also. We enjoy to see different people around us. And I would extend that to the industry we are in. The people we interact with, it's one of the most, exciting part of my job. They're all different. Like I said, I was in India this week, I was in Taiwan the week before. Completely different culture, completely different set of people, different mind, but all extremely innovative, interesting. We work with the smartest, most interesting people on earth in this industry. And we have that in ASML. So, diversity was always a strength for us. And of course, lately, this has been articulated into something different. And I always tell the team, everything we have ever done around diversity, it's not because of the fashion of the moment where, it's good to do it, now it's a bit less good. We always did those things because we fundamentally believe that this is who we are, that this is good for us. And, we are principled people. We're not people that goes with the wind.
Now, as you know, I'm a leadership professor. I have to ask you a few questions on this front. Going through ASML material, a few things struck me. One of them is ownership equals empowerment plus accountability.
So, it's been a very important journey on that discussion. So a couple of years ago, when I took the role of CEO, I felt the need to bring back the concept of ownership. Because ownership means that basically people will take something, they will be responsible for it, they will drive it to the end, and whatever obstacle they meet on the way, They will not say, well, I cannot solve it because this is someone else's problem, or the organization is such that this is not my department, this is someone else's department.
So there's a can-do.
It's a can-do, and it's also the idea that you need still, even if you have a big organization, you need to hone your think. Because if you only rely on a complex organization for things to happen, I think nothing happens anymore. And now to do that, you need indeed to tell people you're in charge. Right, so you have to let them be in charge. You have to create the conditions so that they can act as if they are in charge. So that's the empowerment. But empowerment, I always say, is the part people like to hear. I want to be empowered. And then you tell them, okay, you are empowered. Now you're also accountable, because the rest of the organization will take back this empowerment if you're not accountable. If they see that you don't really hone, then of course you have a problem of credibility, and the whole organization has a problem. So this has been a key focus also as a result of our growth, right? The reason why we felt the need to talk about ownership, empowerment, accountability is also because we saw a risk at losing some of that. And this, ownership is at the key of innovation. If you do complex things, you better hone them to make sure that they go through.
Right.
So we have been explaining our leadership, our people, how important this is. And of course, beyond the words, we do things to enable that again in ASML. But that's, for me, extremely important.
Another thing that has struck me is the emphasis on humility. This comes up often. Also, leadership is a privilege to live up to every day. And maybe those two things are connected. Humility.
Well, I think, humility is absolutely key. It's the idea that it's not about you, it's about something much bigger. It's about the idea that you need to serve an industry, serve society. It's the idea that you have to challenge yourself all the time. Don't ever start believing that you're great or that you are better than the rest or any of that. So always start asking yourself, what can I do better? And do I really understand, I don't know, what my customer needs? Do I really listen? Right? Listening is very important. I always tell people, try to listen more than you speak. Right? There's always value, especially when you travel to see your customer, to spend time listening. So if you stay humble, you learn. If you stay humble, you have the ability to change direction, to adjust, to adapt. If you stay humble, you have the ability to question yourself, to have some self-reflection. I think arrogance is the worst possible things you can ever get in any company. Arrogance will kill any company. It's a matter of time. Humbleness will allow any company to continue to reinvent itself all the time. And, for me, more personally also, you observe a lot of leaders, of course, but when I became CEO also, it was clear for me that, what happened in the last 40 years is very important, right? Sometimes there's this idea that there's a new CEO and change of direction.
Everything starts with you.
Yeah. And I think it's a completely flawed idea, because a company is also the sum of its history. And everyone who has been there, especially the leader, have contributed positively one way or the other. And our role is not to say the past was this, the past was that. No, our role, I think, is to continue to try to improve to the best of our capability. That's the job, basically. So you take something great and you have to make it greater. But to make something greater, I think you have to be very humble.
One of the things I heard you say is, some time ago, I decided I don't have anything to prove to anybody else anymore. I'm free.
Yes. Well, it's something I explain to a lot of people. That's something I think very natural in your career. When you start, you have to prove a lot of things, right? The first job, the second job. So, and you have to prove those things to yourself first. Can I do that? Can I do this? And I think it's a burden. It's a real burden, because when you wake up in the morning with the idea that you need to do something because you want to check
impress
a box,
others,
to
right.
impress others or to impress yourself, I think it takes a lot of your time and energy. And in my own career, you know, I wanted at some point of time to run a business, and ASML gave me the opportunity to do that in 2000, I think 12, 13, so it's already quite a while ago. And then I did it, and it went well, and after that, everything was bonus, I would say. But this change of perspective, yeah, it's really free you, because now you don't come here to prove something. You come with just, well, the question, okay, what can we do differently? What can we do next? So you have a lot more space to, again, create. Right? So that's why it's a bit of a liberation in some way. But I think everyone has to go through that. And you know, when I coach you know, people in the middle of their career, I say try to understand what you do to still prove yourself versus the rest. And the less you do for proving something, the better off.
So you're encouraging people to try
Absolutely.
to move to this liberated state earlier.
Yeah, because it's I think it's a lot more enjoyable, and I think a lot more powerful.
Last question, Christophe. You love your job because?
Well, because of the people that I work with. I think I told you before, I have the privilege to meet unbelievable people every single day. Here, of course, in ASML, there's not one discussion that I don't enjoy, right? Once, I think a customer asked me, how do you do to work so hard? I told him, I never feel I'm working. Of course, I go to the office, very busy, but I think doing what I do is an unbelievable privilege. Being in ASML, interacting with this industry, with the leadership, this is just great. I wish anyone to have that type of opportunity. So I cannot complain, ever.
When you say privilege, I also hear this notion of gratitude.
Yeah, it's because, you know, of course, there's always an element of luck in everything, right? As people say, you better be lucky than smart. I also believe in that because, you know, I don't know why I became ASML CEO. There was no plan, there was no path, it just happened because of everything we discussed. I have done things in a certain way, and it took me here. And that also gave me the belief that I have to continue to do it this way and encourage people to do the same. So there's privilege, gratitude, feeling to be lucky. I mean, yeah, this is an amazing job. There's no question.
Thank you very much, and best wishes of continued success.
Thank you very much.